we are going to go ahead and find the area and perimeter of this triangle here located on the coordinate plane. So this is not an easy triangle to find the area of because none of these sides of this triangle lie flat on boxes, meaning I can't just count to see how long it is. And that's really important because if you recall, the area of a triangle is equal to 1/2. Let me just put triangle there so we recall area of a triangle equals 1/2 base times height. So it's unclear what the base is, it's unclear what the height is, which makes this kind of difficult. So in order to make this a little bit simpler, we're going to use something called the box method. So in order to use the box method, basically we are going to draw a box around this figure, so a rectangle, such that each of those vertices lies on the box. So first I'm going to do it in one color and then I may go back and fix it. So take a look. I'm going to draw a line all the way to the left such that Z is on that line, right? I'm going to do the same thing to the right so that O is there because Z and O are the farthest left and right. Then on top, I'm only going to go as high as O is because that's my highest point there. And on the bottom, I'm only going to go as low as E is because that's my bottom point. I'm going to go ahead and just erase any extra. Okay, so what I did was I drew a box around ZOEY so that each of the vertices is on the box. There's no extra space. Okay, now I'm going to go through and I'm actually going to erase some of this highlighting because I'm going to go ahead and color code it. So I'm going to make this over here green. And I'm going to make this over here yellow. And the purpose of this is so that you can recognize and identify that there are actually a few different shapes here, right? This triangle down here, this yellow triangle, then I have this green triangle, and I actually have this pink triangle. So the idea is I'm going to find the area of the whole rectangle, the big rectangle that I just drew to box that in, and then I'm going to subtract each of those colored triangles out. And what will be left is that triangle ZOEY. So again, that's just the formula up top, so I'm going to kind of mark that off so that it's not a part of my work. But there's 3 areas I'm going to have to find. I'm going to have to find the area of my rectangle. Then I'm going to have to find the area of, I'm going to say triangle 1, and I'm going to put a nice little 1 in my pink triangle. Then I'm going to have to find the area of triangle 2, and I'll put a 2 in my green triangle. And then I'm going to find the area of triangle 3, and I'm going to put a 3 in my yellow triangle, okay? And these are going to be very easy to find the area of. Now, we know the area of a rectangle is just length times width. And I can just count the boxes here, right? So let me go ahead, let me change the color of this pen, and I'm going to count the length, right? So I'm going to say this is 1, 2, 3, 4, 5, 6, 7, right? And length and width is relative, but this is a 7 as one dimension, right? So I can go ahead and put a 7 in here equals 7 times. And if I count my other dimension, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's a 9, right? 7 times 9, which means that my larger outer rectangle is 63. Okay, so 63 units. If I was to count that whole big rectangle, everything filled in, that's 63 units. Now let's take the area of that first triangle, number 1. Now remember, the area of a triangle is 1/2 base times height, right? And if I look, that pink triangle is so much easier than that Zoe triangle because I can see the sides quite easily. One of the sides is 1, 2, 3, and the other side is 1, 2, 3, 4, 5, 6, 7. So I'm just going to use those dimensions. 1/2 times 3 times 7. And I could put all of that into my calculator if I want, but it's going to be half of 21, which is going to be 10.5. Right? All right, so I found the area of my big rectangle. I found the area of triangle number 1 pretty simply. Now I'm going to go ahead and find the area of triangle 2. So the dimensions of that triangle is one side is 2 units. The other side is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So I'm going to have 1/2 times 2 times 9. That's going to be 18 cut in half, which leaves me with a total of 9. All right, we're almost there. Nice and easy, right? So triangle number 3, the dimensions are going to be 1, 2, 3, 4, 5, 6. And also my second dimension is going to be 1, 2, 3, 4, 5. So it's going to be 1/2 times 6 times 5, or 1/2 of 30, which is going to be equal to 15. All right, now this is the last step, which is pretty much the easy part, right? If I was to start with that 63, that big rectangle, and take away all of those smaller areas. So first my pink triangle, so I'm going to subtract 10.5. Then I'm going to take away my green triangle, so I'm going to subtract 9. And then I'm going to take away my yellow triangle, so I'm going to subtract 15. So if I completed this little bit of arithmetic here, that would give me my full triangle. So 63 minus 10.5 minus 9 minus 15 leaves me with a final area of 28.5. So that means the area, so I'm just going to write this out down here, the area of triangle ZOE equals 28.5 units squared. So this is a nice, really easy method. We call it the box method, which could be used to find the area of any figure. You can box in any figure, take the area of the larger rectangle, and then subtract all those little triangles you find along the way. Now, perimeter is a little bit different, and I'm going to leave that for you to do because you know what the perimeter is, right? Now, because I can't count the distances of these lines, I am going to need to use the distance formula. So I'm going to allow you to take a minute to do that yourself, but I am going to help you a little bit with the coordinates. So Z here for Zoe is going to be -3, +2. So -3, +2 are the coordinates for Zoe. If I look at O, I have 1, 2, 3, 4, 1, 2, 3, 4, 5. So this is going to be 4, 5. And if I look at the coordinates of E, that's going to be +2, 1, 2, 3, 4. So this is going to be 2, -4, which means I'm going to have to do the distance formula 3 times. I'm going to have to find the distance of ZO. I'm going to have to find the distance of OE. And I'm going to have to find the distance of EZ. And then once I have all 3 of those distances, I will add them together to find the full perimeter. So I'm going to leave that for you to do now. If you do not remember the distance formula, I will write that here to help you. It's distance equals the square root of the difference of the 2 x coordinates squared plus the difference of the 2 y coordinates squared. Okay, so you're going to use that distance formula. You're going to find those 3 lengths, add them together, and then come into me ready to tell me what your perimeter is.